Solver is a tool used for what-if analysis in Excel. You can find it under the Data tab of the ribbon, under the Analysis group of commands. If you don't see Solver, that's just because it hasn't been activated yet. Here's how to do that. Go to the File tab and click Options. Click Add-ins, and from the Manage drop-down list, make sure that Excel Add-ins is selected, then press Go. Tick Solver Add-in and click OK. The Solver command will now show up on your Data tab. Solver works with variable cells to arrive at an objective or target subject to certain constraints. It's superior to GoSeek because you can use up to 200 variable cells to arrive at your objective, and you can also set multiple restrictions on the solutions that Excel offers. Excel uses variable cells to produce the results you want. So the objective cell must contain a formula, and that formula must be directly or indirectly dependent on the variable cells. So in this example, we run an outsourcing company that handles projects for clients. The workforce management team determines that they'll need to assign or schedule 1,065 agent hours over the next 3 weeks to meet all their clients' deadlines within budget. So that's 1,065 divided by 3. That's 355 agent hours per week. And that's the objective for our weekly schedule, 355 hours. Do we have any constraints? Well, yes, we have a limited number of agents. So let's say that's 10 agents. We have our 10 blank lines here where we'll need to generate valid shifts. And the weekly hours scheduled for each agent will be totaled here in H11 to H20. The grand total of hours will be here in H21. So ideally, we want this to say 355. And we'll also likely have limits on how agents can be scheduled. So maybe we can't schedule people to work shifts that are longer than 8 hours. And maybe everyone is guaranteed at least 20 hours per week, but they can't be scheduled for more than 48 hours per week. Let's plug all these values into Solver by going to the Data tab and clicking on the Solver command. Now we get the Solver parameters dialog box, and let's start by defining the first 3 terms in this window. The set objective field will be our target cell. So in our case, that's H21, and this cell will let Excel know when it's reached a solution. The next field is the to, maximum, minimum, or value of. We'll select max if we want Excel to achieve the largest number while satisfying the constraints. We select min or minimum if we want Excel to select the smallest number while satisfying all the constraints, and we use value of if we have an explicit value. In this case, we do have an explicit value, which is 355. We could link the required hours to a constraint, so it will always be that value. We'll use value of if there's an explicit value. In our case, we do know that our value is 355, so we can enter that here. And how do we want to achieve this objective? By changing certain variable cells. And of course, these are the cells that we want Excel to use to arrive at the objective. So now we can move on to the constraints. That is, what Excel is and isn't allowed to do when trying to solve the problem. In our example, we want to achieve our 355 hours without anyone having to work overtime. So even though agents are allowed to work 48 hours per week, let's say we'd rather them not having to do overtime. So let's add a constraint, which is that these cell references should be less than or equal to 40. And of course, we have more constraints, so we click Add. Maybe we also want to guarantee each agent a minimum of 20 hours per week. So we want to add that here. So this should be 20 hours or more. And now we have some constraints to enter about the variable cells themselves. Maybe the shifts should be 8 hours or less. And we also want shifts to be whole numbers only, so no fractions. So we make them integers. And there are a few other options that we didn't use. So we'd select BIN for binary, if our values must be zeros and ones. And we'd select diff for all different if each value returned should be unique. We don't need those, so we'll keep our integer. And here's a nice little hack, which is a workaround to hard coding an objective or a specific number. We can tell Solver that we want our objective cell to always be equal to a specific cell. So we click OK, and we look at our parameters window. We see that we've entered all the constraints. Of course, we want the unconstrained variables to be non-negative. You'll also notice a few options for your solving methods. One is the simplex LP. This is used for linear problems. So if your variable cells are a direct factor of your objective cell, you'll want to choose this method. And there's no limit on the number of constraints if you use this method. If you use the generalized reduced gradient nonlinear, then it means that one or more of your constraints or variables aren't direct factors of the objective. There's a limit of 100 constraints here in addition to bounds and other restrictions. So if you're using GRG nonlinear, you can list a maximum of 100 constraints. And the evolutionary method is used for non-smooth problems. So if there are some functions that are discontinuous, then you'll want to select this method. And this is usually for the most complex types of optimization problems. So we do have a linear problem here because all our variables are directly related to the objective. And if you're not sure, then you can keep your solving method at nonlinear, which is the default. All right, so now we can set our solver to work. We click on Solve. And Solver found a solution, which we're eager to see. We can see that most agents got 40 hours, one agent got 35, and 2 got 20. And no one had to do any overtime. And all this was done while meeting the objective of 355 hours. Now, when Excel provides a solution, you might want to save your scenario and experiment with a few other options before deciding on which one to use. So let's say that we want to see what would happen if we tried to complete our project in 2 weeks instead of 3. Then we'd need 533 hours. But we want to save the scenario that we have here. So let's go to our parameters window and we can click Load/Save. And Excel tells us that to save it, we'll need 9 empty cells. So we just need to select 9 empty cells here. Click on Save. And we can close the window and just name this scenario 1. In the meanwhile, we can experiment with other scenarios by going back into Solver, changing whatever constraints we like. So let's say we made this 48 hours. Instead of a maximum of 40, we'll do a maximum of 48. So remember that we've linked our objective cell to B6. So Excel will be trying to get 533 hours here. So let's make that 533. That's our value. That's our target value. And we'll click on Solve. Of course, Excel couldn't find a feasible solution because we have a constraint of 48 hours per week per agent. So that's a maximum of 480. And that explains why we can't get 533 hours. Everyone is working overtime, but we won't be able to get to 533 hours. So if we want to revert to scenario 1, we want to keep 3 weeks to complete. Then we click our solver command. And we want to load/save. To load an existing scenario, we select the range that has the saved model, which is this one, and we click Load. Do we want to replace the current model or merge? We want to replace. And we see that Excel has loaded the constraints that we had in scenario 1. So now we can solve. and we'll get our original solution. After you've done 2 or 3 models, you'll get the hang of Solver, and it's totally worth it. Solver can be applied to workforce management settings like this one, but also maximizing profit, financial planning, and budgeting settings. Download the file in the description and check out our other Excel resources to learn how to use other Excel features.
Ready to learn more about Microsoft Excel? Then check out the full course on GoSkills.com. Click the link in the description.